In this video, we're going to talk about why when you take the limit of a bottom-heavy function as x goes to either positive or negative infinity, the result is 0. So let's look at these two limits. We see here as x is approaching negative infinity, this bottom-heavy function, the limit is 0. And the same is true if we make this negative f of x and we go to positive infinity. Folks, you can mix and match negatives of the function, and going to negative or positive infinity, you're going to get the same result. Whenever you have a bottom-heavy function and x is going to either negative or positive infinity, the limit is 0. Let's talk about why the reason that is so, and let's go back to rational functions where we studied horizontal asymptotes in pre-calculus. Recall, if the degree in the numerator was greater than that in the denominator, so-called bottom-heavy rational function, you had a horizontal asymptote at y equals 0. So let's look back at these two functions that we were considering initially, and let's look at their graphs. As you know, folks, the graph of y equals 1 over x looks like this. Okay, so y equals 1 over x is bottom heavy because the degree down here is 1, the degree up here is 0. So this is going to have a horizontal asymptote at y equals 0. So here is our horizontal asymptote in red. And it's also going to have a vertical asymptote at x equals 0 because x is in the denominator. So look what happens, folks. As you move towards positive infinity, as x goes to positive infinity, what does this function do? Well, it approaches the horizontal asymptote, which is y equals 0. Same thing as x approaches negative infinity. As x goes this way, our graph is going to approach the horizontal asymptote of y equals 0. All of these graphs have horizontal asymptotes at y equals 0. Let's look at, real quickly, let's look at 1 over x squared. 1 over x squared is similar to 1 over x, but because of the x squared term, this portion of the graph gets flipped over the x-axis. Again, still has a horizontal asymptote of y equals 0. So as x gets larger, this graph is going to approach y equals 0, and as x approaches negative infinity, the same thing is going to happen. Folks, just to prove it to myself, I went and graphed every function you see here on Desmos, and each case the answer was 0. It didn't matter if I had an even degree function in the denominator. It didn't matter if I went to plus infinity or minus infinity, or whether I had an even degree in the denominator with a negative sign, or if I went to an odd degree in the denominator, negative signs, plus infinity, minus infinity. All of these limits are 0. All of them have horizontal asymptotes, so it doesn't matter which direction you go, whether you're flipped over the x-axis, you are going to approach 0 at the extremes of n behavior. Let's now look at the intuition as to why this is true. And we're going to look at various examples with various combinations of negatives and going to positive infinity, then negative infinity. But let's first consider this bottom-heavy function. What we have to realize is as that denominator gets bigger and bigger and bigger, the entire rational function, the entire fraction gets smaller and smaller. Okay, let's start out where x equals 2. Okay, then we're going to move to where x equals 100 and where x equals 10,000. So clearly, this sequence of x's matches what our limit is doing. It's heading towards infinity. Well, if we substitute 2 for x, we get 1/2. So if this is 1 on our number line, that puts us at 1/2. Now, we're going to make the denominator bigger. We're going to make it 100. So now we're going to have 1 over 100. And it's easier to graph or to plot decimals on a number line. So I'm going to change this to 0.5. And now we're going to plot 1 over 100. That is 0.01. So 0.01, if this is 0.5 here, 0.01 is going to put us closer to 0. Finally, we're going to let x equal 10,000. If we make this denominator bigger, the entire fraction gets smaller. So now we're going to have 1 over 10,000. As a decimal form, that's going to be, let's see, tens, hundreds, thousands, 10,000s, 0.0001. Folks, that's going to put us right here. And look at the trend. As this x is getting larger and we plot it on the number line, we are moving inexorably towards 0. Next, we're going to look at the same bottom-heavy function with x going towards negative infinity. And I think we'll all agree that as we move in this sequence, starting at -2, then -10, -100, that we'll be trending towards negative infinity. If we plug in -2 here, that's going to be -1/2, otherwise known as -0.5. If we plug in -10 here, we're going to have -1/10, otherwise known as -0.1. That means, folks, we're at 0. We only move in the negative direction 0.1 amount. Right there. That's -0.1. Look what happened. As our x value got larger, the entire fraction gets smaller, but that means you're moving a smaller distance away from 0. So by increasing the x value, you moved closer to 0 from step 1 to step 2. Now we're going to do step 3, -100. When 100 goes in the denominator, we're going to have -1 over 100, otherwise known as -1/100th, and that's going to put us even closer to 0, right there. Again, bottom-heavy fraction going to negative infinity, we're moving closer and closer to 0. That's your limit. Let's now analyze this limit, where x goes to negative infinity, of -1 over x cubed. And recall, there's a hidden -1 in front of this fraction. We're going to move x larger negative towards negative infinity. We're going to start at -2 and work our way down towards -100. And when you substitute the negative into this x and cube it, the negative is going to be maintained. And the results are going to be -1,000, -8, -1,000, and -1,000,000. That should be a negative here. Folks, let's quickly talk about how 100 to the third power is 1,000,000. So 100 can be written as 10 squared. And then if we do our power rule, we have 10 to the 6th power, which is 1 followed by 6 zeros, or 1,000,000. Okay, let's go to our number line. We know that this hidden -1 is going to make everything positive. So we're going to be dealing with positive 1 over 8, positive 1 over 1,000, and positive 1 over 1,000,000. Remember, this 1 over 1,000 is going to be 0.001. This is going to be 0.00, etc., 01. And this is going to be 1/8. If we go to our number line, here's 0. Initially, when our x equals -2, we're at 1/8. I don't know what that is in a decimal. Then when we increase to -10, we're at 0.001. I know this is not to scale. Then when we increase to -100, we are very, very close to 0 at 0.00001. Again, as x is getting larger, negative, towards -infinity, the y value is approaching 0. Bottom heavy function. Doesn't matter. Negatives here, negatives there, positive. As long as you're heading to positive or negative infinity, you are going to get 0 as your limit, and it all comes down to the fact that this bottom heavy rational function is going to have a horizontal asymptote at y equals 0.